us start with the lesson. In the previous lesson, we spoke about something called trig identities, and we're going to carry on with that today. But before we start, I want to ask, what are some of the things that you remember from the previous lesson? And I'd love someone to put their hand up or put it in the chat. I'd love to know what are some of the things that have stayed with you from the previous lesson. Who has some ideas? Bonkonkosi, let's go to you.
Hello, sir. Can you hear me?
I can hear you loud and clear.
Yes, sir. What I remember is that there is two types of identities.
Exactly. What were the two? Can you remember?
Yes. The quotient identity and the square identity.
Okay. So the quotient identity is the fact that tan of theta is the same as sine of theta over cos of theta, or you could say tan of x is sine of x over cos of x. So that's great. And then what's the square identity?
It is sine squared x plus cos squared x equals 1.
Yes. Fantastic. We're off to a great start. So those are two major ideas. Does anybody have an idea of how this information can sometimes be applied or maneuvered around? So I just want to have a quick, what do you remember about the square identity? It's a bit of a tricky one. How else can the square identity be represented? So let's unmute. Yep. So let's wait, let's unmute. Okay, I suppose there's a bit going on my screen. So okay, so I think I'll unmute. Yeah. So anybody have an idea about that? Okay. Bonkonkosi, how do you think we can rearrange this identity here? And Maklamola, I think you also have an idea. Okay, so I think maybe I'll write it up. So the idea that I was thinking of was saying that sine squared theta can also be written as 1 minus cos squared theta, or you can write cos squared theta is 1 minus sine squared theta. So that is an important thing to remember, because sometimes you can use it in the different forms. The other thing that you sometimes have to do is sometimes you have to find common denominators. So be aware of how to find a common denominator. And also sometimes you have to be able to factorize. So to give you an example of what it means to find a common denominator, obviously with trig, it's one thing, but if I said to you like a half plus 3 over 5, in order to find a common denominator for those two, the common denominator you want is 10. And in order to get that common denominator, you times the top and bottom by 5 here, and you times the top and bottom here by 2. And what that allows you to say is that 5 plus 6, and so that would give me 11 over 10. So you need to know how to find common denominators, and you also need to be able to factorize. So if I give you something like sine x plus sine x times cos x, and I say to you, factorize that, could you factorize that for me? I want to do a quick little check. Put that in the chat. What is, if I ask you to factorize sine x plus sine x times cos x? And let's go to Letty. Letty, what do you think? What would you do to
so you'd remove sine x and then it would be 1 times cos x. 1 plus cos x.
1 plus cos x, yes. And what that does is sometimes it allows you to cancel out brackets and things like that. So when you've factorized, often it can allow you to cancel, or canceling is another way of saying equivalent fractions. You have equivalent fractions. I think that's the main things that I remember from the last lesson, but are there any other things that come to mind, everyone? Just read all again, could be time. And then I'll unmute. Who has an idea about what else? Did you remember the stuff about left-hand side and right-hand side? So when we have to prove an identity, we choose a side to work with mostly, and the hardest side, wherever that is, might be the left-hand side or the right-hand side, and we work with that to show that it looks like the other side. Makimola, let's go to you.
Yes, I remember that you said on the left-hand side, you said that sin bracket 180 minus x
Yes.
bracket. That one, that is I remember. And you said on the right-hand side, you said that sin x equals to sin x. That is what I remember from the previous lesson. Sir. Yes, thank you, sir.
Perfect. That was great. So what you're talking about there is you're talking about something called the reduction formula. And
yes,
the reduction formula helps us with that. And that is great. You guys are wide awake and are remembering things. This is great, great news for both of us.
Thank you, sir.
So, all right, let's get going with a question. So let us go to a question. So here are, I'll come back to this in a moment. We can start with an actual type of question. So here are some typical trig identity questions. Now, I know they look like a mouthful to start with, but let's just focus on one tonight to start with. And we're going to do this first one together. I want to ask the class, what side should we start with working with? Should we start working in question one with the left-hand side or the right-hand side?
Left-hand side.
Left-hand side. Okay. So left-hand side is sine x times tan x plus cos x. Now, I want to give you a minute or so, maybe 2 minutes, to try and work with the left-hand side and see what you can do to try and make it look like the right-hand side. So I'm going to give you some time now and see what you think you can do, and then we'll talk about it. Okay, so over to the students. I want you to do question one. Off you go. So what are we going to do if our journey to go from the left-hand side to get to the right-hand side? What are the choices we have? That's what you should be asking yourself. Would anybody like to come online and give me some suggestions as to how we might be able to take this question forward? Oh, let's go to you. What do you think we should do first?
So I think that we should simplify the tan of x into sine x over cos x.
Perfect. I would highly agree with you. So you're saying I should do this. Okay, perfect. I agree. What should we do after that? Any ideas?
So if we simplify that fraction, basically, we'll get sine squared x over cos x plus the cos x on the right-hand side.
Yes. Okay, fantastic. You've helped us a lot. I'm going to ask someone else to help us for the next step, but you have given us great guidance. Okay. Here's what I'm going to do some detective work. If I look at what the right-hand side looks like, it looks like one term to me. At the moment, I have two terms. I'd really like these two terms to be merged into one, but I don't want to break any rules. What techniques do I have available to me that I can help to merge these two terms? So if we go to, let's go to Watobe. Watobe, what technique do you think we can use?
Hello, sir.
Okay.
I think we could find the lowest common denominator.
What would that be?
Cos x.
Yes. Okay, so we know we want this to be cos x. How do we make the second term? How do we make the denominator cos x?
Times it by cos x and times the other
Yep.
side by 1.
Okay, almost. You times both the top and bottom by cos x. So if you times the top and bottom by cos x, what you then get is you get this. And that's
Yes.
super helpful because now we have our denominators that are the same. Thank you so much. Okay, hi everyone, we're almost there. What is my next step? Now that I've built my common denominator, I've made it fit. What's my next step going to be? Where to? Let's go back there. So your hand is still up, and if you're still available, but what do you think? Where to?
So I think that we write the term under one denominator, and as we know that sin squared x plus cos squared x is equal to 1, and that's how we get our answer.
Yep. So what we do is this becomes 1. That shouldn't be cos squared, it should just be cos x. Sorry, move this up. Okay. Oh, that's not working. Let me move that up. So this should be cos x, and this over here should be 1 over cos x, which is equal to the right-hand side that I was trying to get to. And so just to point out that this bit over here was replaced with 1. Okay, let's do a quick little vote. Thumbs up if you feel like you understood that example. Thumbs down if you feel like a bit unsure. Just want to get a feel for the group. Okay, now this is what you're going to do next. Next, you are going to have a go at number 2, the green one. And I want you to try, I'm going to give you 2 or 3 minutes by yourself to give this one a go, and then I'm going to come along and help you. So off you go with number 2, and then I will answer questions from those students who have questions to ask now. Okay. So ask yourself, how do I apply the process that I've spoken about? What is step 1? What is step 2? And then let's have a discussion after that. Mahlamola, let's go to you. What's your question?
So my question is, so can we use the right-hand side?
You can start with the right-hand side. However,
Okay.
I think I would start with the left-hand side because it looks to me like it's a bit tougher.
Because
that
as
make
I'm
sense?
seeing it, so sorry, sir, as I'm seeing that it says that bracket sin x plus a tan. So what I'm thinking I could do that is I'm gonna say that sin over cos bracket and bracket again with the sin over 1 plus cos x.
Yes.
Okay.
Okay. So you agree we would start with the left-hand side?
Yes, sir, because now I realize that you said it's easier to start with the left-hand side, not with the right-hand
Yeah.
side. Vice
Perfect.
versa. Yes, sir.
And so I think you were saying that you would substitute that tan x. I would do that. So I
Yes,
would start by choosing the left-hand side and starting to sub that in. And let's give it some time and see how people go. But that's a good first step. Yes.
Okay, thank you, sir.
Cool. So, okay, Loyola is asked, is cos plus sine not always equal to 1? Loyola is not. Only sine squared x plus cos squared x is equal to 1. So that's a really important idea. So it's not true that cos x plus sine x is 1. It's sine squared x plus cos squared x that equals 1. And so we are working with this left-hand side. Okay. So now this gets interesting. We've made our first choice. We've probably got about 2 marks in the bag, but now something has to happen to unravel this mess. It doesn't look to me like I can do too much over here. There's not really too much going on here. I think we probably could do something over here, but I want some suggestions from the class as to what they think we can maybe do to yeah, in that bracket. Who has an idea? Who has an idea for this one? So let's go to Kat. Kat, what do you think? Can you hear me, Kat? I don't know if the audio is working so good. Okay, let me, Paul, did I see that your hand was up? What was your suggestion for the second bracket?
So I was suggesting that we should multiply by cos x as our lowest common denominator.
Yes, I think, okay, so you're saying you kind of want to stick these two together. And the way we're going to, and I say stick together informally, the way you're going to do that is you times top and bottom by cos x. And if you do that, you'll then get cos x times sine x over cos x. And then you still got this stuff here. So that's the one bracket. And then the other bracket is just sitting over here.
Yes, yes.
I like that. I think there's hope in that approach. What do you think the next step is going to be after that?
So in the first bracket, that over the same denominator, so we can just put them together. And then,
So, yeah, so you can basically do this, which makes sense because you're trying to put them together.
yes.
Awesome. Thank you so much. I think we're making some progress. It doesn't look like it yet, but I feel like something's going to help us get over the line here. Okay, everyone, let's just do a quick little vote. Thumbs up if you followed what's happening in number 2 so far. So let me zoom out. We started with number 2. We chose the left-hand side, and we've basically been working in this bracket for the moment. Give me a thumbs up if you're following. Give me a thumbs down if you feel a bit like at sea here. Okay. So there's a mixture, and that's fine. Remember, you can rewatch this later, so that we are stepping it up a notch here today. So what was the other, if you think back to the beginning of the lesson, what is another technique that I suggested that maybe might come out later in the lesson that might be useful here? Who has an idea as to what technique? I'll give you a hint. It's got to do with this patch over here. Yes, 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 yes. It is to factorize. So what type of factorization? Is this a difference of 2 squares, or what type of factorization am I going to use? Common factor, yes. And what's the common factor going to be in that yellow expression? Oh, fantastic. So I have sine x, and inside the bracket, I'm going to have something, and then on the bottom, I'm going to have cos x. I want to know from everyone in the class what goes in this bracket here. So I'm trying to factorize the yellow bits. What do you think goes in that part over there? This part is just going to stay the same because I haven't touched it. So I think if I took out sine x, the cos x is left behind, and here there's a 1. So I would have cos x plus 1. Yeah. Okay, now, what can we do next? These two are being multiplied. There's something rather interesting about these two. What do you notice about these two expressions? Who feels like I want to come online and give us a human voice to explain what I'm pointing at? Aha, so Kat and Loyolo and Impo have said, since they are the same, they could be cancelled, yes. And that's really what I was hoping for. So if I do that, this and this are equivalent to 1. So that's what we mean when we cancel. We say, you know, cos x plus 1 is the same as 1 plus cos x. They can be cancelled. So now I'm left with sine x over cos x times by sine x. Okay, now we haven't finished the question yet. Let's go back and make sure we can see it. What's my final step here that I'm going to need to do? What's my final step going to be here? I wouldn't say cancel. So let's go back to where we're going. We really want to get to the right-hand side. That's the promised land. That's where we're going. What do I need to do in order to get there? Ah, Tebogo, Kat, I think you're onto something. I think that this bit over here can be changed to tan x, and this is sine x. And then because it's multiplication, I can just rewrite it as sine x times tan x, which is equal to the right-hand side. And so that is a proper difficult trig identity question. So let's go back from the beginning and just make sure we understand the steps that I was doing, because I think that we're going to do 2 more of these today, but it's helpful to look at the steps. So what was the first step that I did? The first step was to pick a side. Right, so pick a side. The second step that I did was I substituted. So I changed the tan x into sine x cos x. The third step was a common denominator. And that was when I tried to knit these two things together. Now, fourth step was to factorize and cancel. And then the fifth step was to substitute again. So when I substituted sine x over cos x for tan x, and then I suppose the last step, I could say I just made equal to the other side. So those steps that we did. Okay, now, just quick little, before we have our break, thumbs up if you feel like you can follow the steps, thumbs down if you feel a bit lost. I don't expect everyone to be there yet. This is, it's a tough section, but we're going to get there. We're going to practice. But I hope that you see some of the ideas that I introduced at the beginning of the lesson, how they're coming through now. Okay, so don't worry, there's still lots of time in today's lesson to keep practicing. But what we need to do now is we need to take care of our brains so that our brains take care of us. And what that means is that we are going to stand up. So I want you on your feet, and I want you to turn your cameras on. I want to see all your energetic faces. And I'm going to go full screen so you can see me. Wait, that's not on the right setting. Okay. Let's leave it like that. Okay. Can you, can everybody see me? Give me a thumbs up if you can see me and you can see my happy avatar. Okay. Let's do that. And start like that. Okay. Let me see there, and then let me, now if I do that, there we go, that's better. Okay. So what I want you to do is I want you to start by just swinging your arms. And I want you to take a nice deep breath. Breathe out. Okay. Then let's roll our shoulders. So 5 rolling backwards. And 5 rolling forwards. Okay. And then I want you to do is I want you to twist. So slight rotation to start with. And then gradually, as your body relaxes, I want you to twist a bit more. You should find as you relax, you can twist further. Okay, then let's do a meridian crossing exercise. So take your hand, put it on your nose, take your other hand and put it on your ear. And we're going to switch by taking the hand that's on your ear to your nose and the hand that's on your nose to your other ear. And then once you've done that, see if you can switch back. And see if you can do that a couple of times. See if your brain has figured it out. See if you can do it as quick as this. Okay. One more thing. So make sure you've got a clear space around you. We're going to do some high heart rate activity. So we're going to do some jumping jacks. We're going to do 10 of them. And we'll start in 3, 2, 1. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And down we sit. Okay. And I brought you some quality. Well, let's do a Maths 24 question to just get us going. So the red and the blue to start with. And then if you guys munch that up, I've got a 3-dot question to extend you further. How do we get to 24 using? Okay, so Hitzel, you said 7 minus 5, so that would be 2 plus 1 times 8. That will only get to 10 according to my calculations. So I'll give you a hint. Think about if you go 8 minus 5 and you get 3. How do you get to 24? So the way Maths 24 works is that you need to use each number once. And you can only use plus, minus, times, divide, and brackets. to get to 24. So I've used 8 and 5. What else can I do to get to 24? Aha, yes. So Naledi has said 7 plus 1 can give us 8. And what can we do with the 8 and the 3 to get 24? Well, we can just go 8 times 3 is 24. Or Tebogo has said 8 minus 5 is 3 times 7 plus 1. And so that would be 3 times 8, which is 24. Oh, here's another one. 7 times 5 is 35. And then 35 minus 8, which is 23 plus 1. 7 minus 5 is 2 times 2 plus 4. There's a couple of other ideas, but I'm pretty, so there's definitely one way of doing it, and then there might be some others. Let's just see if we can do the blue one as well. Can you get to 24 using the 4 numbers on the blue card? Yeah, and today's one was definitely harder. Yeah. Oh, here we go. Here's another one for the red one. The blue one, you're right. Oh wow, Letu, you were on form there. So 8 times 2 plus 7 plus 1. What does that give us? It gives us 16 plus 7 plus 1, which is 24. Do you guys want to see a yellow? Do you want to see a 3-dot mass 24? Give a thumbs up if you want to see a 3-dot, thumbs down if you don't. Okay. Here is a 3-dot mass 24 question. Can you get to 24 using 3, 1, 8, and 8? See what you can do with that. The 3-dot just means it's harder, Letu. So it just means they should be harder. Oh, look at that. And Paul, where did that go? So there might be another way of doing this, but so if you go 8 times 3 is 24, unfortunately, you still have to use the other numbers. You have to use them all. So you're correct in that you've got to 24, but you have to find a way to deal with the other ones. But here's the hint. If you go 3 minus 1 is 2, that's what Paul has recognized. How can we use that 2 to get to 24? So you can say 2 times 8 plus 8, which gives us 24. Or for Misa and Kitso, I've also had an idea. 3 minus 1 times 8 plus 8, 16. Yeah. So let's have a look. There's a couple of different ways we could do this, but I think the 3 minus 1 seems to be the most important bit. And then once we've got that, we can use the 8s. We times by 8 and then plus by 8. Okay. Well done, everyone. That was very good. Let's get back to our trig identities. I think we've had a break and our brains are ready to roll again. So here is what I want you to do. Let me actually create some space so that our brains can focus on just question 4. So let me take a screenshot. And let me put this over here. I want you to try and prove this trig identity. I want you to use whatever steps you think might be useful. I'll try and leave some of the stuff up. Actually, you know what? It's probably better if you don't see those steps, that you have to force you to remember them. So let me put that on the screen. It's the only thing we're going to be dealing with. And I want you to do your best. And then I will take questions from the class if there are questions. Ooh, Sorry. Okay. So what side should we start with? I think the left-hand side, but there could be two ways of doing this, but I'm going to suggest the left-hand side for now, because it just feels that it looks harder to me of the two sides. What do you think our first step should be? Who has an idea for the first step? Just put it in the chat. And I mean, it doesn't look like we have too many options here. I think we just have to do what we can. Yeah, tan. I mean, tan is the only thing we can do. So I think I would make this sin x over cos x. I wouldn't change this yet. I wouldn't change this one yet. I mean, it's not wrong to. I could change it at the same time, but for the moment, I'm just going to go with that term at the bottom. Now, having a fraction like that is tricky. Is there some way I could make this term a little bit easier to deal with? What mathematical technique could you bring in here? If you got a fraction divided by a fraction, can't I write this as 1 minus cos x over sin x? And then I could also write this as, maybe now I should write this as sin x over cos x. That for me is starting to look a little bit easier, but I'm still not there yet. But at least I'm on the road. Now, if we are going to go down this road, I'm going to get stuck again at this next step. So what do you think I need to do, or what are some suggestions from the class about, now that I've got these, at least it looks a little bit simpler, and that's good. And if I look at the question that I'm looking at, yeah, it looks like it's possible. What do you think I need to do next? Yeah, LCD. Kat, what would the lowest common denominator be, or a common denominator be for this one? I kind of have to force it, but both. Yeah, Naledi, exactly. But how would we get both? Well, we would times this. I'm running out of space. Let me zoom in a little bit. I would times this by cos x, and I would times this by cos x, because cos x over cos x is 1. It doesn't change anything. And over here, I would times this by sin x over sin x. Now, what would my next line then look like? I suppose this would be cos squared x. And then I'll rewrite this neatly, sine x times cos x. And on this side, I would have sine squared x. And I have sine x times cos x. So the good news is I've done the job of making the denominators the same. And the way that I made them the same was I times the top and bottom by cos x in the first term, and I times the top and bottom by sine x in the second term. Notice that sine x over sine x is the same as 1. Cos x over cos x is the same as 1. And 1 times anything doesn't change anything. So that's why we can use this trick. It almost feels illegal, but it's not, because 1 doesn't change anything. Okay, so that's the technique that it really comes through strongly tonight. Okay, but it still doesn't look the same as the right-hand side. This is where we're trying to get to. What's my next step going to be? So top, yeah. So if you want, you can put the step in like cos squared x plus sine squared x over sine x times cos x. So that's fine. But really, this is just going to be 1 over sine x times cos x. Okay, now that's looking pretty simple. But what you notice is that the same as the right-hand side? Is that the same as the right-hand side? Yes or no? No, it's not. So sometimes when this happens, it doesn't feel like I can do too much more on the left-hand side. So you know what I'm going to do is I'm going to leave the left-hand side like it is, and I'm going to ask you to have a look at the right-hand side. So if we look at the right-hand side, I'm going to give you some more time now. Can you try and simplify the right-hand side? What can you do to simplify the right-hand side? Give it some time and give it a go there. What is my first step to be with the right-hand side? It feels like this tan x should be changed. So I'm going to get sine x over cos x. And so this is going to be sine x times sine x. But here is another, this is a bit of a tough one. I'll give you one more trick. If I had on the bottom sine x times sine x over 1, what can I do with that? I think I can use the top and times technique, where I go, this becomes times 1 over sine x times sine x. Okay, so let's have a quick look, because this is sneaky. This is me being a sneaky maths teacher. Everybody is happy that sine x over cos x is the same as tan x. I have written this as being over 1 because it's helpful to me. Now I'm dividing by a fraction. When I divide by a fraction, can't I top and times it? So I flipped it over and I changed this to a multiplication. Yes. So for therefore, I know that this is a bit of a sneaky one. So think of it like this. If I had 1 over 2 divided by 3 over 4, would you be okay with me saying 1 over 2 times 4 over 3? Would you be okay with that? That's what I'm doing here. I'm saying that I've got sin x times sin x over 1. And then if I change this to times, this goes to the top here and this comes to the bottom here. So Anele, don't just hang in there, and you'll see that this makes, I'm going to go over this from the beginning at the end here. Where's the 1 coming from? So Tato, that's a great question. If I take a number, so if I take 8, for example, and I divide 8 by 1, what will I get? So Tato, what would I get if I go 8 divided by 1? What do you think? Or anyone in the class, what do I get if I go 8 divided by 1? I get 8. So does 1 change anything? No. So if I've got sin x times sin x over 1, it's still sin x over sin x. But the reason it's helpful is it allows me to think of this thing as a fraction. Okay, so it helps me think of this thing as a fraction. And if it's a fraction, I know that I can just change it to a sin x over cos x was the top times 1 over sin x sin x. Okay. Now, in the chat forum, I can see that Zukiswa said the signs cancel out. Yes, the signs cancel out. Now, why does this make me a little bit excited, everyone? What is left behind? I now have a 1 on the top, and on the bottom, I'm going to move the sin x to the front, and then I'm going to move this one to here. So what does that show? What is that going to be? So I have a look at this, and I look at that. That was quite a question. So now I know that the right-hand side is equal to the left-hand side, and I've proved this. So I'm going to go from the very beginning and go through all steps so that everyone can kind of see what we did. That was about as tough as it gets, but that's why you're in the standard class. I'm showing you so that you can see the types of questions that, if you want to kind of move up in symbol ranges. So at the very beginning, we chose the left-hand side because it seemed like the easiest thing to do. I did a substitution, so there was a sub. I used top and times to get from 1 over sin x over cos x down to this thing over here. So that was top and times. I'll call it TT. Okay. Then what I can then see is that I put things together and I made a common denominator. And then from there, what I'm going to do is I put them together and then I did a substitution and then I got to this point here. Then I started working on the right-hand side. And when I worked on the right-hand side, I did a substitution to start with. And then I did a top and times. And then I did a cancelling essentially. And that was it. Okay. So I would encourage a lot of you to watch this lesson again. It was a tough lesson, but if you keep going over these techniques, you'll see that a lot of the ideas kind of come up again and again, and it gets easier. So I just want to know in the chat, before I put the link to the quiz for this week, how are you guys feeling at the moment? Do you feel like you can see yourself improving, or do you feel, give me a thumbs up if you feel you're improving at this. Give me a thumbs down if you feel completely overwhelmed and lost. I just want to get a feel for the group. Somewhere in between. Okay, now, I think for a lot of students, it was a tough lesson. And so can I suggest that the recording becomes available tomorrow? Re-watch the lesson and see if it is any easier the second time you watch it. It is a tough topic, so it's hard to do the entire thing in 2 lessons. But yeah, if you re-watch it, I have every faith that things will get easier. Okay. So what I'm going to do now is I think Simone is back with us. Simone, are you with us?
I am. Apologies for that.
Can you put the link to the quiz for the week in the chat? So in the quiz today, there is questions like identities, but there's also some revision questions from earlier in the topic. And so if you could just make sure that you do this by the end of tomorrow, it will give you a good revision of all the stuff that we've covered in trigonometry, although it focuses more on identities. And I just want to encourage you guys, like this section, you do need quite a lot of repetition. But the good thing about Watobe is that you can re-watch this lesson, and we will also do exam prep and things like that. So just keep repeating and you will see that the structure will get easier. I don't want you to be discouraged because I know some of you might feel a bit like overwhelmed right now. You're doing well, and I have every faith that if we keep practicing, you will improve. Okay.